Good morning. Today's topic is causation. And we have to keep moving along here. So this is one of the concept of causation is one of the central concepts in philosophy. Earlier on in the course, I'd referred to Aristotle's theory of causation. Remember, there were four causes that Aristotle recognized: the formal cause, the material cause, the efficient cause, and the final cause. I may have mentioned then that in contemporary philosophical thought, philosophers mainly focus on what Aristotle called efficient causation. Roughly, efficient causation for Aristotle is occurs when there's a change which results in something happening. So basically, you can think of efficient causation in terms of an event or occurrence making another event or occurrence happen. So striking a match, say, produces lighting of the match. Would be a case of efficient causation. Or a sculptor performing a series of actions results in a statue coming into being, which was one of Aristotle's favorite examples of efficient causation. Also, say, the reproduction of an animal by means of, say, reproductive processes producing an offspring. So you have a change producing an event of some sort. So viewed from that perspective, if we're focusing just on efficient causation and not looking at final causes and formal and material causes, which seem to be quite distinct kinds of explanation of certain results. We're focusing on efficient causes, so to speak. One of the issues that confronts us from contemporary ways of thinking is what exactly is the ontological category of the relata of the causal relation. So one answer suggested by what I've said already is that the relata of the relation of causality, causes and effects, which are causes and effects, are basically events. So that's one quite popular view. So that when X causes Y, X and Y are events, things that happen, as opposed to, say, substances like animals and statues and things of this sort. So that's one view. Of course, that leaves open the question of exactly what are events, but from the common sense perspective, anyway, events appear, at least, to be concrete spatiotemporal entities of some sort, which have the property of occurring. So they seem different than substances which don't occur. like a table doesn't occur, but say the table's burning, if someone set fire to it, would be an occurrence. So occurrences typically have temporal parts. So there's the first half of the event and the second half of the event, which can in turn be subdivided into quarters of the event and so on. Substances, though, would appear to have temporal parts only if we accept the idea of a space-time continuum, four-dimensionalist view. Otherwise, they seem to endure and not to be composed of other substances of shorter duration than themselves. That seems to be more appropriate for events from the common sense perspective than for substances, unless we assume that space and time form this unity. Then it seems like we're forced into accepting the idea that material objects would all, by virtue of being four-dimensional space-time objects, have parts which have both spatial and temporal dimensions. So then we'd have to say that, you know, there's the part of you which is your childhood and the part of you that's your adolescence and your mature self, and these would all be parts added together that make up you. So you and other substances in space-time would be four-dimensional space-time worms, or things composed of stages that have various temporal lengths. Right, so if we adopt this ontology of events, whether we believe in a space-time continuum or not, these events would be composed of other events, and so on, be subdividable, it seems, indefinitely, if we follow Zeno's way of thinking anyway, or for a very long time until we reach some minimal atomic quantum length of some sort, beyond which you can't divide them anymore, according to the atomistic view of space and time. Right, so one perspective is going to view the things that enter into causal relations as these temporal happenings or events, such as striking the match, producing burning of the match, and so forth. So that's one way to go. But there's not universal agreement on this, interestingly. I mean, you would think everybody would accept the idea that the terms of the causal relation are events. But there's quite a bit of disagreement about this. Some say that the terms of the causal relation are not always events, and this raises some doubt then about whether the event hypothesis is right. One alternative is to say that it's states of affairs that are the terms of the cause and effect relationship. So the idea here is that a state of affairs is a more abstract kind of entity than an event. So whereas events are concrete, states of affairs seem to be more like abstract entities, at least on one view of states of affairs. So you could say that there's a state of affairs of 2 and 2 equaling 4, necessary state of affairs. I mean, if we do say that, then states of affairs are abstract objects. there's certainly no concrete event of 2 and 2 equaling 4. Right? So, nor is it clear that all events involve changes. Excuse me, I misstated that. Nor is it clear that all causes involve change. So we can think of some causes that might just be states, not involving any kind of process or change. So what would be an example of something where we say it's not a change that produces the result, but just sort of an unchange or state of affairs? Consider a tabletop. If you ask, what's the cause of the tabletop, say, being 4 feet off the ground? Imagine the legs of the table has 4 legs, which are 4 feet long, and you ask, what's the cause? What causes the tabletop to be positioned relative to the ground in the way that it is, namely 4 feet from the ground, and so forth? Or say lying being positioned parallel to the ground as well. Right? So what would the cause of that be? It would seem to be, say at a certain moment, the moment at which we're assessing this. Suppose the table's been there for 3 months, but we ask, why is the top 4 feet from the ground and parallel to the ground today? The answer is going to be what? That the legs are all of the same length, and they're all each leg is the same length as the others, and that length is what? 4 feet. Good. So that's what seems to be the cause of the tabletop being 4 feet from the floor and parallel to the floor, is that the legs are all 4 feet long, and that would explain it. Right? That would be the cause. But there's no change. There's no change involved. I mean, I'd say there was a change involved when the table was first built, right? Then there were changes. But if we're assessing it today and the table's been there for months and we're asking why is the tabletop 4 feet off the ground now, the answer is going to be, well, the legs are 4 feet long now. And if it was 3 feet off the ground, then it would be because someone had cut a foot off each of the legs, say, 6 months ago or something, right? But today it's 4 feet off the ground, because 3 feet off the ground, because the legs are 3 feet long now. Right? So this is the kind of way we talk about causation, I think. So not clear that there has to be a change or an event involved in every cause. There might be some causes that just consist of static states of affairs, say. So the idea here is that a state of affairs is more of a factive kind of entity, a fact. So some say that it's not events, but facts that are causes, where facts are expressed by propositional clauses. So the cause of the match's lighting, of the fact that so suppose we have the fact that the match lights and the fact that the match is struck. So couldn't we say that the fact that the match is struck produces the result, which is the fact that the match is burning? Right? So here we have facts entering into a causal relation, expressed by propositional clauses like that, such and such is the case. These seem to be the same as the objects of other propositional attitudes like beliefs. So someone can believe that the match is struck, and that the match is struck, it seems, can be the cause of the fact that the match lights. So we have two different models here that we could use, either causes as events or causes as facts. And there's a spirited dispute in metaphysics about whether it's concrete occurrences, concrete events, which are kind of structureless, concrete entities, or whether whether those are terms of the causal relation, whether those are the causes and effects, or whether it's these more abstract factive entities or states of affairs, obtaining states of affairs, that are the causes and the resultant effects. So that's an issue. There are some advantages, I think, to each approach. Then there's a question of whether substances can be causes. So consider an ordinary statement like the moon is causally responsible for the tides and oceanic tides. So there we seem to say the moon causes the tides. So there the cause seems to be the moon. But the moon's a substance. It's not either a fact or an event. It's just like an object. But it seems perfectly acceptable to say that the moon causes the tides. So in that case, we have a substance, apparently anyway, acting as a cause. I suppose you could say, well, it's not, even though we talk that way, it's elliptical for some statement about the moon and its properties, which could be either an event or a fact. Like the moon's having a certain gravitational mass. The moon's having a certain mass is what causes the tides to behave in the way that they do. Then it could turn out to be a fact, right? The fact that the moon has a certain mass. Doesn't really seem to be an event in the sense of a change anyway, right? It's not any change in the moon that causes the tides. It's just the moon's being there, right? With the mass that it has and the gravitational force that that massive satellite acts on the tides, right? It pulls them. Pulls the water through gravitational attraction, resulting in these high tide and low tide. So there's a question then about whether we literally think that the moon is causally responsible, or whether we want to understand it in terms of these more complex causes. Another kind of example would be agency. Living things, including people, is the most obvious case anyway, causing things. So that would be an example. Say John causes his arm to go up. Or John makes his arm go up, right? If you want to be a little more colloquial about it. But making and causing are the same thing. There are lots of causal verbs. Matter of fact, a lot of the verbs we use have causality built into them. Like if you say, the stone broke the window, you're making a causal claim, right? Because it's implicit in the meaning of breaking, that breaking is a causal relationship, whereby the stone causes the window to break. So John makes, so making is a causal verb. I think it's pretty much synonymous, actually, with causal. Whereas breaking is a certain type of causing, right? Not all causes are breaking. Some are ignitings, and some are extinguishings, right? And some are breakings. And so. But making just seems to mean causing. So we could say the stone makes the window break when it breaks it, and so forth. So John makes his arm, his right arm, go up. So this is agency. You have an agent making something happen, performing an action. Here again, we seem to have a substance as a cause. John's a substance, he's not an event or a fact, right? It doesn't seem to be the case anyway. But, he falls into those categories. He seems to be a substantial being, yet it seems reasonable to say that John makes his right hand go up. Or should we say again that it's a more complex event or state of affairs that makes the hand go up, and not John himself? Not simply John, but John's, undertaking to make his right hand go up is what causes his right hand to go up, which would be an event or state of affairs. John's trying, right, or undertaking to make his right hand go up. So what do you think? John's undertaking, or willing, as it used to be called in the olden days. There's what's called a volitional act. John's undertaking to make his right hand go up is what causes, or what makes his right hand go up. John's undertaking to make his right hand go up makes his right hand go up. So now we have event or state of affairs causation, the state of affairs of John's undertaking to make his right hand go up makes his right hand go up. So it would be now a relation between, say, two events or states of affairs or facts or whatever, one causing the other. But what makes, how does John make, or cause his undertaking to make his right hand go up? It seems like John makes that happen too. Makes it happen that he undertakes to make his right hand go up. Does that make sense? I mean, or is that something that just sort of happens, having nothing to do with John? Does it just sort of happen that he undertakes to make his right hand go up? Or is it something that John makes happen? If he does make it happen, right? If he does make it happen, then it doesn't seem like it could be caused really by anything other than John. The only other thing that could cause it, I think, would be John's undertaking to undertake, right? John's undertaking to undertake to make his right hand go up, which seems to be nonsensical. Whatever, we don't undertake to undertake. I don't think. Or if we do, we don't undertake to undertake to undertake, whatever. I mean, at some point it stops, right? We can't go back infinitely. Okay. If we don't say that our undertakings or decisions or willings are caused by us, then it's hard to see how we can be responsible for what we do. If you say it just happens that John undertakes, there's no cause, whatever, or it's something other than John, then it's hard to see how John can be responsible for anything that he does. If we say that he does cause these things, then it seems wrong to say that the cause of these things is some further event, like John's undertaking to undertake, or undertaking to undertake, and so on and so on. So at some point it seems, I mean, if we go back a couple of steps with these higher level undertakings, we're going to stop And at that point, we're going to have to say John causes the undertaking in question, it seems. Otherwise, we're going to have people not responsible for what they do. So that would be the argument. If you want to play devil's advocate for the idea of agent causation, that is, an agent being a cause as opposed to any event or state of affairs. I guess one way out of that would be to have a theory whereby we can say that John causes his undertaking, but somehow that gets reduced to some event or state of affairs involving John causing his undertaking. And perhaps there is such a theory available. But that would be the way you'd have to go. Because I don't think we can leave these events, these volitions or undertakings detached from John causally. They have to be connected to John causally. But I guess they could be connected to him through the fact that he is a part of an event, say, of his undertaking to do something. Perhaps there'd be a way to connect the event or undertaking to him in the appropriate way through his being a part or constituent of the undertakings in question. Since he is the one who's undertaking it, after all. Right. The things get rather fuzzy there, don't they? So there remain a minority of philosophers who do believe that substances, especially agents, can be causes. And some would even argue that that's the most basic sense of causation, whereby substances produce effects, including the moon and living things and people and so on. Though clearly agents would fall in some specialized categories, since they're quite different from inanimate objects like moons. So we have these at least these three candidates for terms of the causal relation. There are even those who say that qualities, concrete particular qualities, are terms of the causal relation. These tropal entities, like the particular mass of the moon, right, and the particular qualities of the water. Right? So the particular mass of the moon is what produces the particular qualities of the tides. So that would be another possibility. Have properties as the terms of the causal relation. So it's the moon's massiveness, right? That particular massiveness that causes the particular motions of the tides. So properties, concrete properties, right? Tropes, in other words, what we've called tropes, could be terms of the causal relation. Probably not worth considering any more possibilities than these four. I think that's more than enough. Right, but you could see how each one makes sense. Though the consensus seems to be that it's something like events or facts that are the most likely candidates. One problem with having substances as these causes is that it really doesn't seem possible to formulate universal principles or laws of nature just in terms of substances without bringing in their properties and so forth. And that seems to be taking us towards the other views, that it's properties or events or states of affairs or obtaining states of affairs or facts that are the actual or deeper terms of the causal relations. Because it seems pretty clear that causal relations in the natural world depend metaphysically on there being some kind of causal order to things expressed in terms of laws of nature. So I want to turn next to the concept of a law of nature. Before I do that, are there any questions about? Okay, laws of nature. So I've said that there's an intimate connection between laws of nature and cause and effect, causation. So what's an example of a law of nature? Well, these laws, first of all, are universal and in some sense inescapable, otherwise we wouldn't call them laws. Now it's true that societal laws, so like the laws of the state of North Carolina or federal laws, whatever, can be violated. And you go to jail, say, or pay a fine if you violate the law. The laws in that sense are not natural. They're artificial in the sense that they're humanly created things. Natural laws hold, or laws of nature or natural laws, hold independently of what of the conventions of human society or any other decisions that human beings might make about things. So what would be an example of a law of nature? It's got to be some principle that always holds concerning natural phenomena. That's required for a law of nature. There may be more involved as well, like some kind of inevitability or inescapability or necessity, one might say. Though exactly what that necessity comes to is a perplexing, controversial issue in the history of philosophy and among contemporary philosophers. The context for the debate about laws of nature and causation as well in contemporary or modern philosophy was pretty much initiated by the great British empiricist David Hume. His writings on causation and natural law are seminal for these modern and contemporary discussions. We'll be talking about his views in a bit. So what would be an example of a law of nature? Well, it seems like a true law has to not have any exceptions to it if it's a natural law. Right. It has to hold at all places and times in the universe. So this makes it perhaps a question about whether we can actually know what the laws are. But the thought is that if we have a random sample of the universe, whatever, and we find that certain principles always hold, then we can extrapolate and say that they probably hold everywhere. Right? So one example of such a principle, did you have one? Yeah, the law of gravity says that any two objects attract each other depending on the distance between them and their masses. So the greater the distance is, right, the weaker the forces, and the greater the mass of the objects, the stronger the forces. So mass and distance play off each other here to determine the degree of gravitational attraction between any two bodies. So it says, the law of gravity says basically that any two bodies in the universe attract one another in a manner directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So it's like body 1 and body 2, right, that have mass 1 and mass 2, right? Attract one another by a formula which says that you multiply mass 1, the mass of body 1, by the mass of body 2, m2. So you multiply m1 by m2, and you divide by the square of the distance between body 1 and body 2. Okay. And there's also a thing called a gravitational constant, which is a number that you multiply m1 times m2 divided by d squared by this constant, g, which is an empirically determined number. And that gives you the strength of the gravitational force. Okay, so that's supposedly a law of nature. Newton had some basic laws of nature. So another one was that force is equal to the product of mass and acceleration. Right? And then there was a law that said any body at rest will tend to stay at rest unless something moves it. And any body in motion will move in a straight line if left unimpeded by anything. So a body at rest will tend to stay at rest. A body in motion will tend to stay in motion unless it's stopped by something. And then he had another one which was for every action there's an equal and opposite reaction. So these are some basic laws of physics. Einstein said it's a law of physics that the speed of light is the fastest attainable, is the fastest speed that an object can be accelerated to. Actually, you can't reach the speed of light, but you can get closer and closer to it. Unless the object is, say, a photon, which can go at the speed of light. So I guess a photon could go from less than the speed of light to the speed of light, because they can slow light down now by using various methods, laser beams, and you can trap like a little piece of light triangulate it between laser beams at very low temperatures, like in liquid cesium or something like that. And basically they can stop it. But then when you take that stuff away, it's going to start zooming off again, right, to go back up to the speed of light. So that seems to be acceleration, right? So it seems like light could accelerate from less than the speed of light to the speed of light, which is interesting. But no other things can. You couldn't do that with a table. It can't reach the speed of light. It's only because light has no mass that you can do that. A motionless photon has no mass. Therefore, when you speed it up, its mass isn't going to increase. It's just going to stay massless, which allows it to travel at 186,000 plus miles per second. All right, so we have various examples of these natural laws. So it's got to be a universal generalization, like that all bodies attract energy. Right? So it might be tempting to say then that in giving an explanation of what a law of nature is, to say that any true universal generalization expresses a law of nature. Unfortunately, that's not correct. Not all true universal generalizations express laws. Even if you exclude those that are logically or metaphysically necessary, like all bachelors are unmarried, say. So we exclude those and say they're not natural laws, even though they're true, because they are tautological and don't express any kind of natural cause or causal relation. We're still going to have some true universal generalizations that don't express natural laws. So what would be an example? Well, one thing about universal generalizations, like all F's are G's, is that they're said to be vacuously true when there are no F's. So what this says is for any X, if X is F, then X is G. But if there are no F's, then that will be vacuously satisfied. So if there are no things that are F at all, the universal generalization will be true. So if you say that all unicorns are purple, right, that'll be a true universal generalization. Will that be a law, though? No. Why not? Well, it doesn't seem to be necessary that physically necessary or any kind of natural law that unicorns be purple. Why should a unicorn have to be purple? They might be white, right? Normally we would think they would be white. Certainly don't have to be purple, right? So if a unicorn was suddenly to appear, we wouldn't think that it, have any reason to think that it would be purple. So one of the problems in just in identifying laws with universal generalizations is going to be that we have universal generalizations with false antecedents that are vacuously or trivially true. Can we fix that in any easy way? Can we say that all laws have non-vacuous antecedents? Could we assume that? Say, well, that's not a law because laws always have instances. It's not clear we want to commit ourselves to that, right? I mean, there might be some laws which are true laws, but the situations they cover haven't existed. I mean, couldn't that be the case? Why would we want to foreclose on that possibility? that there might be some laws that hold for some highly improbable situations that have not occurred. Is there a guarantee that they will occur at some time? Well, probably don't want to assume that. So that would be a risky move. So the thing about laws, as I've said, is that they have to have some kind of inescapability to them. I mean, when we think of gravity, we're not simply saying that any two bodies attract each other, but that any two bodies would attract each other. There's no way to prevent the bodies from exerting this gravitational or attractive force. And by saying there's no way to prevent that, I don't mean that there's no way that humans can prevent it. What I mean is that there's no physical or natural phenomenon that can prevent gravitational force from being exerted. There are things that can counteract the force or neutralize it. Objects might be attracting each other, and some other force could pull those objects away, right? So that from each other, counteract. Magnets, say, could pull the objects away, so that they're not moving towards each other. So something could counteract or neutralize the force, but the gravitational force would always be exerted, and would need some equal and opposite force to neutralize that. So there's an inescapability to laws, and for this reason, we have to distinguish between law-like generalizations and accidental generalizations. Accidental generalizations are universal generalizations that are true, okay? But their truth is accidental and is preventable by other factors. So we have to distinguish an accidental generalization from a law. So an example of an accidental generalization would be, say, that, let's see, anything in my left pocket is a cell phone. So all things in my left pocket are cell phones. So that's a true generalization, but it's not a law. And why isn't it a law? Well, if we were to put my keys in my left pocket, which I'm not going to do, so I'll keep that true there. But if I were to put them in there, they wouldn't morph into a cell phone, right? They wouldn't become a cell phone. And then the law wouldn't be a law because it would be false. But provided we don't do that, we have this true generalization, which is not a law. It's something that could be false, so to speak, in some sense, even though it's actually true the way things stand. The same thing like if a red bird lands on your front lawn, then all birds on your front lawn are red. Suppose a family of red birds lands. There's like 4 of them, whatever, right? So all the birds on your front lawn are red, but that's a true universal generalization, but it's not law-like. Because if a crow landed on your front lawn, he wouldn't suddenly turn red. Right, so what's the difference then? Well, this is the distinction between the two is often explained or unpacked in terms of the idea of what are known as counterfactuals or contrary to fact conditionals expressed in the subjunctive mood. Subjunctive mood is when we use the word would. So the idea is that laws or law-like generalizations support or imply contrary to fact or counterfactual conditionals. So suppose it's a law that bodies that have high thermal conductivity, a body has high thermal conductivity if and only if that body has high electrical conductivity. I suppose we take that to be a law, seems to be a law. So it says that a body has high thermal conductivity just in case it has high electrical conductivity. So either way, right? If it has high electrical, it has high thermal. If it has high thermal, then it has high electrical, like copper, right? It's a good conductor, very good conductor of both heat and electricity. Those two always go together for any given object by law of nature. So then we could say that if a certain object were to have a high degree of electrical conductivity, then it would have a high degree of thermal conductivity and vice versa. So that would be a true counterfactual conditional with respect to this law. The law linking thermal and electrical conductivity in bodies, saying that they're codependent, right? Supports these counterfactual conditionals, that if a body were to have one of the properties, it would have the other property. But it's not true that if a thing were in my left pocket, like a book or a wallet or whatever, that it would be a cell phone. Or if a bird were to fly on your lawn, it would be black. Red. We had red birds on your lawn, right? So if a bird were to fly into your lawn, it might be black and wouldn't have to be red, even though all the birds on your lawn may be red. So you can have a true universal conditional that's true just accidentally. But to be a law, the universal conditional has to, in some sense, be true necessarily, and therefore to support these contrary to fact conditionals about what properties an object would have were it to satisfy the antecedent of the law. If it were to have the property F, it would have the property G, as opposed to it just being accidentally the case as things happen to stand that everything that has the property F has the property G. If it's on your lawn, then it's red. So this is an important distinction between universal principles that are laws and those that are merely accidentally true. This raises a big question, though, about the kind of necessity that laws are supposed to have. What kind of necessity is that? And can we say that laws truly are necessary in any sense at all? This question is going to arise because it's hard to figure out exactly what kind of necessity they can have. So the first kind of necessity they don't seem to have, at first blush anyway, is logical necessity. I mean, it doesn't seem that a law is true in the same sense that, say, it's true that all red things are red. Because laws don't seem to be tautological, trivial truths. They seem to express some kind of non-analytic connection in nature. So we seem to be in an uncomfortable position of saying that laws are in some sense necessary, but not necessary in the way that the laws of logic are necessary. So the it's a law of logic, for example, that nothing can both be and not be at the same time. That's the law of non-contradiction. It doesn't seem like the law of gravity is true in the way that the law of non-contradiction is true. Because we can't imagine or conceive of something that both is and is not at the same time, right? It's inconceivable. The negation of a law of logic is inconceivable, like the law of non-contradiction. But the negation of a law of nature does seem to be conceivable. And that's the source of the problem. Is it inconceivable that you have two bodies that don't attract one another? It doesn't seem inconceivable at all, right? It's easy to conceive or imagine that you could have a possible universe where there are bodies that just sort of float out there and they don't attract, right? Why do they have to attract? It doesn't seem to be necessary. Because it's so easy to conceive, it seems quite possible that you have a universe in which there are bodies that don't attract one another. You could even imagine a world in which bodies inherently repel one another, so, a repulsive world, where bodies exist more or less in fairly solitary splendor because they repulse everything away from them. Right? Yeah, so it doesn't seem like it doesn't appear, at least at first sight, that we can view natural necessity of laws of nature to logical necessity or metaphysical necessity, if that's different than logical necessity. Some philosophers distinguish logical necessity from metaphysical necessity. They say that logical necessity only obtains when the statement is tautologically true. It's a law of logic. Like all things that are F and G are G, or everything is G or not G, things like this. So these are logically necessary truths. Or it's false that P and not P. Another logically necessary truth, an expression of the law of non-contradiction to which I referred to earlier. For any proposition P, it's false that both P and it's false that P. Metaphysical necessity, on the other hand, is as strong as logical necessity in that it's absolutely impossible for a metaphysically necessary proposition to be untrue, just as it is for a logically necessary proposition. In other words, there's no possible world in which either a truth of logic or a metaphysically necessary proposition are false. The difference, though, is that metaphysically necessary propositions are thought to be non-tautological, to not be reducible to laws of logic. An example might be the proposition, though this is controversial, that all red things are colored. Because it seems like the terms red and colored are both indefinable in terms of any other concepts. And if that's the case, there'd be no way to exhibit all red things are colored as a logical truth. Another example might be the proposition that 2 and 2 equals 4, because, again, it doesn't seem possible to reduce that to a law of logic. And the concept 2 plus 2 is not the same as the concept of 4. As Kant observed, 2 plus 2 equals 4 does not mean 2 plus 2 equals 2 plus 2. 2 plus 2 equals 2 plus 2 is a uninteresting tautology, whereas 2 and 2 equals 4 is a blank you need to fill in, on an exam, maybe in first grade or whatever, but it's still a discovery. It's not repeating the very same thing as you have. It's, in other words, not a tautological statement. Or pick some more advanced math, like 7 and 5 equals 12. Or any other true equation. We can't equate the meanings of the one side with the meaning of the other side. So we can't reduce it to, it seems like we can't reduce it to a tautological statement. All right, so it doesn't seem like either metaphysical necessity or logical necessity would apply to the law of gravity, though. Doesn't seem to be the case that the law of gravity is either of those, because we've, as I've argued, it seems fairly easy to conceive or imagine of the law of gravity not holding. So it seems to be a contingent proposition that any two bodies attract one another in the way specified in Newton's law. Now, we could bite the bullet and say, even though it appears to be conceivable, it's still not possible for Newton's law to be false. It's only because of our ignorance that we think we can conceive of bodies that don't attract each other. But if we knew the true essence of bodies, which is perhaps deeply hidden from us in the nature of things, we would agree that bodies necessarily must attract one another. But we just can't see that. But it's nonetheless a necessary truth, either logically necessary or metaphysically necessary. Well, I guess that's possible, but how do we establish that? Why couldn't there be some kind of weird type of matter in some other world that just behaves differently? Why does it have to behave? Just not a very convincing argument. But there are those who opt for that because it doesn't multiply kinds of necessity. We just have this one kind of necessity, or two kinds, perhaps, and laws of nature would fall under one or the other of these basic kinds of necessity. If we don't take that route, we're going to be stuck with finding some different kind of necessity that laws have. Or we're going to have to say that laws aren't really necessary at all, ultimately. That was the route that Hume took, as we'll see later, of saying that laws aren't really necessary at all. Hume was skeptical about any necessary connections among distinct matters of fact. And is unwilling to accept the idea of some kind of deeply hidden necessary connections that we have no way of verifying or observing. For Hume, all there is the observed conjunction between F and G. He says that in typical cases of laws and causal connections, we observe a constant conjunction of events or objects of two kinds, that they're always associated together. But that's all we can observe. We can't observe any necessary tie or nexus or connection between the two. So laws for Hume are just express conjunctions of properties of F's and G's, which have no, as far as we know, actual necessary connection. So for Hume, all we can say basically is that there are these accidental connections. We can't verify that they're necessarily connected. So what happens to our counterfactuals and things? Well, we'll see what Hume's response to that is later. Basically, he's going to take a kind of subjectivist view of these things and say that the necessity we feel is a kind of mental compulsion or psychological compulsion to draw the conclusion or to believe that whenever you have an F, you'll have a G, due to the fact that we've repeatedly observed the conjunction of these two. We form a habit whereby if we observe an F, we expect a G. So we're under a kind of mental compulsion to expect a G whenever we encounter an F, due to the habitual association of these two in our experience. More on that later. If we don't take Hume's way out and say that there is no necessary connection ultimately, that it's just a subjective thing, that subjective association that we attribute to the object, so we're kind of anthropomorphizing, according to Hume. We're taking a compulsion that we, a sense of expectation or a sense of inevitability that we have about two events that we've habitually seen associated. And so we've habituated the idea, and then we project that feeling into the world. So we're saying that there's some kind of necessary tie between thermal conductivity and electrical conductivity, or between smoke and fire, and so forth. Because we've habituated events of these, or states of these two sorts, objects of these two kinds, of the kinds in question, whether fire and smoke, or electrical and thermal conductivity, or whatever. We habituate the two through association, and then there's a psychological compulsion which we project into the objects in the world. So we think there's got to be a necessary connection between fire and smoke, and between one body and another when they gravitate. There's got to be some kind of necessary thing going on when it's just in us. So we're projecting an inner psychological state out into the world, which is one form of anthropomorphizing things in the world. Like, whatever, if we thought that clouds and the sky and the rain had personalities or something akin to that, analogous to that. Though here we're not attributing a personality, but we're attributing something analogous to a feeling that we have, a feeling of association between two things, to saying they must be associated in the world independently of our mind as well, beyond just the fact that they're constantly conjoined, that they're necessarily constantly conjoined in some sense. Now, this is what the strategy that Hume takes to get out of the problem of introducing either a new kind of necessity or claiming implausibly, admittedly, that laws actually express logically or metaphysically necessary ties, which seems wrong due to the fact that we can easily conceive or imagine contrary universes where gravity doesn't hold, where things that are causally connected in the actual world are not causally connected at all in these other conceivable, imaginable, or possible worlds. So what other alternative is there? Well, it looks like we would need to say that there's some other kind of necessity. that holds. If we're going to say that it's not logical or metaphysical necessity, one possibility is to say that there's some other kind of necessity, call it physical necessity or gnomic necessity. So this is what some philosophers have said, that there's a sui generis, that means a unique and special kind of necessity that applies to natural laws. Gnomic necessity. Gnomic just means law-like. So this doesn't tell you anything about what it is. Just giving it a fancy title. Gnomic necessity, sometimes known as physical necessity. It's physically necessary, but that just means it's a law of nature. Physical necessity. So the argument is, well, look, these laws of nature support counterfactuals, unlike accidental universal generalizations that don't support counterfactuals. Counterfactuals deal with what would happen if some condition were satisfied. That's clearly an expression of some kind of necessity. It's saying something more than every time this happens, that happens. It's saying if there were to be something, it would have that same property. And we've seen that you can have a universal generalization that's not, that does not support counterfactuals, like all the objects in my left pocket are cell phones, right? Which is true, but wouldn't support a counterfactual. So if you have one that does support a counterfactual, like all things with high electrical conductivity have high thermal conductivity, then there must be some kind of necessity had by that law that things with high thermal conductivity have high electrical conductivity and vice versa. There must be some kind of necessity, but that necessity is not either metaphysical or logical necessity, because we can easily imagine things being otherwise, that things that in some possible world conduct electricity without conducting heat and vice versa. Right? So the conclusion is then that there must be some special new type of necessity that these physical laws exemplify. They must exemplify some new type of, novel type of necessity that was hitherto unnoticed, that supports these physical, contrary to fact conditionals. Like if some new element were discovered that had a high degree of thermal conductivity, it would conduct electricity really well, right? We find some new element, whatever, right? Digging on some alien planet or whatever, right? We can say, well, if it has this property, it'll have that property, right? Or if we find some new type of matter, we can say that bodies made of that type of matter will attract bodies made of this other. Would attract bodies made of this other type of matter if the law of gravity is accepted. Now, it might be the law of gravity is not really a law, but we discover it doesn't apply to. Right? But assuming it is a law, and that's our assumption, then it would support counterfactuals about any possible pieces of matter. So many philosophers of science accept this idea of a unique, special type of necessity that applies to laws. Those that don't, though, and who accept the Humean intuition that laws of nature aren't necessarily true in all possible worlds, which seems pretty plausible, have to find some subjectivistic account of law-likeness, since they won't be able to say that laws are truly necessary in any sense. So looks like those are our two main options here. Those some do try to defend, as I've said, the idea that laws possess logical or metaphysical necessity, but the two main views seem to be either there's some special, unique, different kind of necessity that laws have, which we intuitively grasp through these examples and so forth. Or they argue for some kind of Humean or neo-Humean argument, response, according to which we can explain the necessity we attribute to laws in terms of subjective or psychological factors, so that it turns out that laws aren't really necessary at all. They're accidental generalizations that we view in certain ways, or which figure into our norms and practices in some kind of ways, or something like that. We can look at some of those alternatives briefly next time. So I'll let you all go now. See you on Thursday.